these are your 5-6 notes on the remainder and factor theorems. 2 rules that we're going to use, and they both involve using synthetic division, but they just use it slightly different than what we're used to. So if you understood the concepts of synthetic division, I think you'll be okay with today's lesson. We're going to start off by just reviewing synthetic division. So if I was to divide this polynomial here by this binomial factor x minus 3, I would put a 3 up in the corner. I'd write down negative 16, 80, and 5. Bring down the negative 16. Leave a space where the remainder would land. And 3 times negative 16 is negative 48. 80 plus a negative 48 is a positive 32. 3 times positive 32 is 96. And 5 plus 96 is 101. And so what we would write is negative 16x plus 32 plus the remainder, 101 over x minus 3. Remember that the degree that you started with and the degree of your answer is just one less. It's called a depressed polynomial. So now we're going to change gears just for a second and review the concept of finding a value of a function, f of 3. So using function notation, I'm going to plug 3 into that same polynomial. So if you look at this polynomial here, it matches the one from above, and coincidentally, the f of 3 matches the number that we divided by up above. So if we were to do this, wherever I see x in the actual function, I replace it with 3. I use parentheses. Take care when you plug this into your calculator, making sure that you don't make any mistakes. And I get negative 144 plus 240 plus 5. And when that's all said and done, f of 3 is equal to 101. And I notice that I've seen 101 before up above. And so I'm making the connection that when I find the value of the function for 3, I get 101, and when I use synthetic division of the same function using 3, I get the remainder 101. And so somebody made that connection early on, and they made a proof, wrote a proof, and they actually found out this happens every single time. So it just opens the door that if you ever want to find the value of a function, you don't necessarily have to plug it into the function like below. You can use synthetic division and just interpret the remainder part. And so that is the remainder theorem. If you have a polynomial and it's divided by a binomial, x minus a, then the remainder is the constant f of a. So just to reiterate there, it's kind of an abbreviated form. If I have the factor x minus a goes in the corner. After I do the actual synthetic division and finish everything off, this answer here is equivalent to if I were to plug in f of a. So it's a new method to find the value of a function. You're going to use that method today. When we use synthetic division to find that value, it's called synthetic substitution. So it just changes the name a little bit. So we're going to actually apply that down below here twice. So we're going to find the value of f of 10. I just want to reiterate that if we're finding f of 10, that we are actually going to put positive 10 up here, and that it relates to the factor x minus 10. So it already, the sign has been changed. And so I look through my equation. I've got a 1, a negative 10, a 1, a negative 8, and a 1. So 1, negative 10, 1, negative 8, and 1. I'm going to go through synthetic substitution, and my solution will be the remainder. So 1 times 10 is 10. Add it to negative 10, you get 0. 10 times 0 is 0. Add it to 1, you get 1. 10 times 1 is 10. Plus a negative 8 gives you 2. And 2 times 10 is 20. Add it to 1, and you get 21. You can verify the answer on your calculator, but that means that f of 10 is equal to 21. So instead of plugging in 10 into that whole function, taking it to the 4th power, taking it to the 3rd power, and multiplying it by negative 10, adding it to 10 squared, subtracting 8 times 10, and adding 1, we simply went through that little subtraction or the synthetic substitution and got the answer. So they both work. Both methods will work. But I do realize, I think it's longer to use the calculator and there's more room for error. So we were making those mistakes here and there. And so we just want to make sure that we don't have that happen over and over again. So let's try it again. G of -2. We're going to put -2 up in the corner. And then I just got to put some placeholder values here. So I got to put a placeholder for 4 and then 2 and 1. So we get 3, 0, -5, 0, 0, 57. Honestly, it would probably be easier to just plug this one into the calculator because we just now made 3 terms into 6. But oh well, you have to do it this way anyway. -2 times 3 is -6. Add it to 0, you get -6. You get 12. Add it to -5, you get 7. -14 added to 0 is -14. 28 added to 0 is 28. And the last one is a -56. And when you add it to 57, you get 1. So really, when you use synthetic substitution, you're not too worried about everything else. We're going to ignore all of this stuff, and we're only worried about that number there. This is your proof that you did it. But G of -2 is equal to 1. So that's the first half of our lesson, is to use synthetic substitution, you interpret the remainder, and you find the value of the function. The second half involves another rule, another theorem called the Factor Theorem. And this is just a rule that says if you actually go through the synthetic substitution process and the remainder is 0, then that means the number up in the corner goes into it evenly, or the factor goes into it evenly. Think of a regular number. If you don't have a remainder, that means the number that you divided by was a factor of that number. So this is a new method of being able to factor crazy polynomials. This is when our other methods of factoring don't work. We can use this method. So what they're basically saying here is if you have this x minus a as a factor, if I divide a into the synthetic substitution and you get 0 for the remainder, a is a factor, or x minus a is a factor of the polynomial. So some terminology here. A depressed polynomial is the degree less than what you started with. Okay, so it's always 1 less than the previous polynomial. It's what's left over. So this stuff right here is the depressed polynomial. And after we do the synthetic substitution, you may or may not have to factor that again. So you'll always look to see, could I factor the other polynomial? So what we're trying to do here is write our polynomials in factored form using the synthetic substitution. So let's go ahead and try it here. So you can see that they give us a polynomial, and they actually give us one of the factors. So remember, when you write these things in factored form, we're trying to figure out what was this before it became x cubed plus 7x squared plus 2x minus 40. They're telling us x minus 2 goes into it. So x minus 2 could be multiplied by x squared and something else, or maybe x minus 2 is multiplied by another quantity of x and another quantity of x. We got to get x cubed. So it could just be the first choice if this polynomial doesn't factor, or if that factors again, maybe it becomes the second choice. So they're actually giving us one of the factors, which means this x minus 2 should divide it evenly, which means we should get 0 when we do the synthetic division. So I'm going to put a 2 up in the corner, 1, 7, 2, -40. And the whole goal, if they told me that x minus 2 is a factor, x minus 2 should go into it evenly, I'm anticipating 0 here. So really, I'm not concerned with the 0. I mean, I want it to equal 0, but I'm more concerned with the actual division part now. So I go through the process. 2 times 1 is 2, plus 7 is 9. 2 times 9 is 18, plus 2 is 20. And 2 times 20 is positive 40. And when you take a negative 40 and a positive 40, it does equal 0. I always make it a smiley face. That means I did it correctly. My depressed polynomial is what I'm interested in here. This was x cubed, so that means this one represents how many x squareds we have, plus 9x plus 20. So right now, that is the remaining factor. I look to see if I can factor it some more. If I can't, we leave it alone. But I notice what multiplies to give me 20 and adds to give me 9 are 4 and 5. So this becomes x plus 4 and x plus 5. So these are the remaining factors. So I just kind of want to put it all together for you. They gave us x minus 2. We found x plus 4 and x plus 5. All of them multiplied together give us the original problem that was here. So that's the factored form of that function. And it actually tells us a little bit about the function. If we were to set it equal to 0, we could say that this graph crosses at 2, at -4, and at -5. We would have 3 x-intercepts by looking at the factors, just like we did with quadratics. But for today, when we do our homework, the only answers they're going to give us are the remaining factor or factors. When I read off the answers, the one they gave us, the x minus 2, won't even show up. But you can put it in there and I won't mark it wrong. Let's try another one. Giving you a little tricky one here with the 3 out in front of the x. So if there's a 3 out in front of the x, we have to divide by 3, divide by 3. So that's going to give me x minus 2/3, which means 2/3 goes up in the corner. Going across the page here, I'm going to have a 2, a -25/3, a 2/3, and a +8. I'm going to bring down the 2. Now this shouldn't be too bad because again, my remainder should equal 0. That's the goal. 2/3 times 2 is 4/3. When you add 4/3 to -25/3, that's -21/3, which is -7. -7 times 2/3 is -14/3. Sorry about the bell. -14/3 plus 2 is -12/3, which is -4. And a -4 times 2/3 is -8/3. And I think I made a mistake here. That should have been an 8/3 when I divided by 3. I forgot to divide that last one by 3. So it does in fact work. So I got 0 for my remainder. The depressed polynomial, if the original was degree 3, my depressed polynomial is 2x squared minus 7x minus 4. I got to see if that factors. So because of that 2, that makes things a little complicated. Little review and factoring. We got to make that little chart and say what multiplies to give me -8 and adds to give me -7. And the answer is -8 and +1. So I got to split this middle term up into 2x squared minus 8x plus 1x minus 4. Split it down the middle. I'm going to divide this by 2x. Take out a 2x, take out a 2x. That leaves me with x minus 4. Divide by 1, divide by 1, take out a 1. That leaves me with x minus 4. Because these two quantities match, I can put those two outside quantities together. 2x plus 1 times x minus 4. So these are the remaining factors, along with the original one, that would give you the factored form. Now, if it doesn't factor, then you leave it as a trinomial. Some do and some don't. So your lesson summary, we have the remainder theorem. I want you to find the value of f of 3 using synthetic substitution, so using the remainder theorem. And then for your practice problem, I want you to find the remaining factor or factors, if it factors again, if I give you the factor x minus 5. Good luck.